Welcome back to the channel, everyone. Thanks for the support. In today's lesson, we're going to be walking through how to do the nucleophilic addition mechanism. This is part of a wider series I've done on organic mechanisms. The links for all of those lessons are in the description below to help you with your studies for A-level chemistry and advanced placement chemistry. So with that said, let's take a look at today's example, which is a ketone, propanone, turning into a hemiketal, which is basically an alcohol with a methoxy group attached. So don't be put off by the name of the product. And with any form of addition, like with electrophilic addition as well, you always have two things becoming one thing. Is sort of the basis for the mechanism. So in electrophilic addition, you have the double bond adding something to create a saturated species, and then similar thing here with the carbonyl bond, C double bond O. So the reaction here is catalyzed by acid, and that means the catalyst participates in the reaction but is not consumed. So we have to get that back at the end. So as with any other mechanism, the first thing we need to do is put on all relevant dipoles and charges so we can see what is going to attack where. So delta positive, delta negative on the carbonyl, and then CH3, COH, the lone pair will be in the oxygen. So this is the nucleophile. So remember, the definition of a nucleophile is a species with a negative charge alone, or a lone pair of electrons, which is attracted to electrophiles. Okay, so that's what the dipoles would look like. So let's think about how this one starts. So first of all, we have the catalyst, and what happens is the lone pair on the oxygen of the carbonyl is attracted to the H+, and this sort of activates it, makes it more reactive. Okay, so then we end up with this species where the oxygen has now got a positive charge, and the nucleophile, the nucleophilic addition part, comes in the second stage. So we have the CH3 and the OH. The lone pair is now going to be drawn to the delta positive on the carbon, and then that pushes the electrons up onto the oxygen, like so. So now we end up with this species, and you will see the oxygen at the bottom is now carrying a positive charge because it's used this lone pair to form a dative covalent bond to the C double bond O. Right, in the last step, the H+ is released. So, by the way, all of these steps are reversible. And this H+ is formed by this OH bond breaking there, and the electrons going back on the oxygen. So if I just zoom in, so you can see that. And then this takes us through to, so minus H+. This takes us through to CH3, O, and then COH, which is the hemiketal that is shown there. Now this is part of a series of reactions and part of a bigger mechanism, but that is the nucleophilic addition part. And as you can see, the catalyst is taken in the first step and is given back out in the last step. So you have the H+ kicked back out in this final step. So we say that it's been regenerated, and thus fits the definition of a catalyst, which is a species that participates in a reaction but is not consumed. Okay, so just to summarize, the nucleophile has a lone pair that attacks an electrophilic center, which is the delta positive on the C double bond O. Then it pushes the electrons up onto the OH. Then the H of the CH3OH on the bottom, this part here, loses a H+, to release the catalyst back into the solution, and then we're left with the product, which is the hemiketal, which is that final part there. Okay. Right, so this is one of 2 nucleophilic addition videos I have produced, so please see the link below the description of this video to check out the next one.